That's question number 8. Question number 8, you remember what we are solving? We are solving JAMB Chemistry 2022 from 1 to 40. This is the question number 8 for it. But remember, while you are joining us on this platform, you make sure that you subscribe. Subscription is very necessary so that whenever we upload any new video, you'll be able to get notified. So subscribe is real. Now, question number 8 said a gas X diffuse twice as faster as gas Y if the relative molecular mass of X is 32. Relative molecular mass of X is 32. Calculate the relative molecular mass of Y. Then they give us the option. I don't know until when I get towards solution. When I solve it, I'll be able to know the real answer among the option. Then now, before I go into this, let's record it. The rate of diffusion of a gas is inversely proportional to the square root of its density or molecular weight. Who said that? Graham's what? Law. The Graham's law tells us that. That is, the rate 1 over rate 2 equals to what? Density of 2 over density of 1 equals to also the molecular weight of the 2 over molecular weight of the 1. Then where D is the density, as I've already explained, can we go now to solve our own? And look at the question. Since we have recorded this, let's look at the question. They said a gas X diffuse twice as what? Faster as the what? Y. So if I now said let a rate of what? Y be equals to 1, then what will happen? The rate of what? X will be what? 2, because it's twice. It said what? The gas X diffuse as faster as twice as faster as gas what? Y. Then now if gas Y is what? 1, then gas X will what? The rate of gas X will be what? Twice of Y. Then now, if the relative molecular mass of what? X is 32, then what did they give me? M means what? Relative molecular mass of what? X is equals to what? 32. Then what they ask me now is M of what? Y. Relative molecular mass of Y is a question mark. Then I can come over here to use the formula. Then if I now ask, calculate the relative molecular mass of what? Y. If I say that what? R Y over what? R X is equals to square root of what? Mass of what? X all over mass of what? R Y. And when I have this, I can now say this implies that Y is 1 all over what? 2 is equals to what? The square root of what? The mass X is the what? 32 all over what? The mass of what? Y. I cannot make anything inside the root. I cannot get anything inside the root until I what? Remove the root. I cannot make use of anything inside the root until I remove the root. And how did I remove the root? We what? Square the both sides. For me to remove this root and make this my subject to formula, I have to what? Square the both sides. If I square the both sides, I have 1 over what? 2 all what? Squared is equals to what? Square root of what? 32 over what? M what? Y all what? Squared. That's what I have here. And this is the 1 all squared. Look at what I mean by squaring both sides. Then what happened here? This will give me 1 squared all over what? 2 squared equals to this one. Now when you square anything root, when you square root, it will leave you with what is inside the root. As I square this, it will leave me with what is inside the root. I think you have noted it now. When I square this out, it will give me what is inside the root. I'll have what? 32 all over what? M what? Y. Then now this will give me, this implies that 1 squared is 1 and the 2 squared is 4 and is equals to what? 32 over what? M what? Y. Making this subject of formula, we do cross multiplication. Cross multiplication will give me 1 times my equals to what? 4 times 32, and that gives me that my my is equals to 4 times 32. This give me 8, this give me what? 12, that give me 128, and that's me the mass of what? X, gas X, relative molecular mass of gas X. Let's go to option now, and I'm getting to this option. A is 64, option B is 128, which is what? My answer. I can answer my answer is a what? Option what? B. That's my answer. This is the question number 9. Question number 9 said an hydrocarbon has an empirical formula CH and a vapor density of 39. Determine its molecular formula. They give him C is 12 and H is 1. Look at the option. I can't know which one is the correct option until I solve it. Can we go to solve? Solution. We go to solution. I remember that what? Molecular mass, molecular formula is equals to empirical formula. Empirical is equals to empirical formula, that's empirical formula, multiplier times multiplier, and also is equals to relative molecular formula is equals to relative molecular formula, that's it. And this man is also equals to 2 times vapor density. 2 times vapor density. That means that this man molecular formula is equals to what? Empirical formula times its multiplier. This n is called what? Multiplier of empirical formula. And is equals to relative molecular formula. And also is equals to what? 2 times vapor density. So this means that I can equate any of this. I can equate empirical formula equals to what? Relative molecular formula. I can equate relative formula equals to what? 2 times vapor density. So any of these can be equated. So can I go to the question now? And what they give me, knowing this now, what they give me what? The empirical formula, and they give me what? Vapor density. So which one will I relate now? I will relate empirical formula to vapor density, which means that what? My what? Empirical formula is multiplied by multiplier is equals to 2 times what? Vapor, 2 times vapor density. I think you have seen based on the question they give me. That's why I equate this one to this. I get what I'm saying. Then what is my empirical formula? They gave me empirical formula. Come over here. They said it has an empirical formula of what? CH. My empirical formula is what? CH. Come down here and see what we are doing. Empirical formula is what? CH times what? N is equals to vapor density times 2. What is the vapor density they give me? Come over here. Vapor density is a what? 39. That means times 39. Can you come down here? Then doing that now, I will have this. What's the C? The C here, looking at C is only 1. That's carbon is only 1 here. I have 1 times 12, which is the number of carbon, molecular mass of carbon. I get what I'm saying now? Plus hydrogen here is 1. I will now say what? 1 times what? 1, which is the hydrogen they give me, is equals to what? 2 times 9 will give me what? 18. 2 times this will give me 78. Are you following now? Can I come over here? I will now have that what? This is, come over here. I have multiplier equals to what? 78. Then now, I can now have this to be what? 12 plus what? 1 times my multiplier equals to 78. I can now say that this is 13n is equals to what? 78. Therefore, I can now say n is equal to 78 divided by what? 13. I can now say n is equals to what? 6. So this man now times this will give me what? 6. Then that n is what? 6. Then now I can now say my molecular formula, my molecular formula is equal to my what? Empirical formula is equal to empirical formula times what? Multiplier. Then now I can now say that my molecular formula is equal to what is in my empirical formula. I have calculated the empirical formula to be what? CH, which they gave me, times what? C. That my multiplier is what? 6. Look at my multiplier, N, which is what? 6. Then opening it, I will have what? That C is what? 6, and what? H is what? 6. That means that my what? Molecular formula is this. Why my empirical formula is this? Molecular formula is this. My empirical formula is what? This. So molecular formula is this. I can now go to my option and I see that option A is what? This. That my answer is option what? A. Yeah, this is question number 10. He said, calculate the percentage composition of oxygen in calcium triiosocarbonate 4. They now give us calcium to be 40, carbon to be 12, and oxygen to be what? 60. That's the atomic number of those things. So look at the option they give us. The option they give us, I don't know until when I calculate. I can now go to what? Solution. And I know that what? Triiosocarbonate can be what? Calcium triiosocarbonate is stated as this. And now what will I do? I have to calculate their molecular mass. Molecular mass of the calcium triiosocarbonate, the molecular mass will be, how many calcium is here? 1. I will now say 1 times what? 40, which is this man now. Then how many carbon is here? 1. I will say plus. I will now say 1 times what? What is the carbon? 12. I get what I'm saying now. Then plus again. How many oxygen is here? 3. I will now say 3 times what? 16. And what does it give me? It will give me 40 plus what? 12. And plus this will give me 18. This will give me what? 48. That means 48. Then what they ask me is the percentage of what? And this, when I add it together, this plus this will give me what? 52 plus this will give me 100. That's 100. That is the molecular mass of what? Calcium triiosocarbonate. That's what I have calculated. Then now, what they ask me is that calculate the percentage composition of what? Oxygen. That means the percentage of oxygen in what? 100 gram of this what? Triiosocarbonate. Percentage of oxygen in 100 grams. So what will I do? I have to, what is the amount of oxygen? The amount of oxygen here is 48. I would then say 48 divided by what? 100, which is the total, times what? 100%. You know what I did? 48, which is the quantity of oxygen in this compound, over the total of what? Elements in the what? Compound, which is 100, the total mass of elements in the compound. This is the mass of what? Oxygen. Then over this, that's what? 100. And that will give me what? 48 times 100% divided by what? 100. This will destroy this, leaving me with what? 48 what? Percent. That's the 48% of what? Oxygen are in the what? 100 gram of what? Calcium triiosocarbonate. That's what it means. Then let us go to option. My option here, which is option B, will be the correct answer. When I say my answer is option what? B. That's the question number 11. Question number 11 said, how many protons, neutrons, and electrons, respectively, are present in the element? Look at the element X. So, question mark. They give us the option here. Let us go to solution to know the option that is correct. Solution. I can recall that what? This man. I can recall that Y this way. I have what? A here, and I have P. It implies that this implies that what? The A is equals to what? Neutron plus what? Proton. Are you get what I'm saying here? And I say where A is equals to what? Atomic mass, atomic mass, or mass number, or what? Mass number. Atomic mass or mass what? Number. And I call it atomic mass or mass number. Where N is my N is equals to number of neutron. Where is number of what? Neutron. That's number of neutron. Then now P is equals to atomic number. Atomic number. This is atomic number. This is atomic number. Or we call it what? Number of electron. Number of what? Electron. Number of electron. So atomic number is same thing as what? Number of what? Electron. So if I know this, can I come over here and looking at this, what they gave me, using this formula now I've stated mass number is equals to number of neutron plus what? Proton. And looking at the question they gave me, come over here, you see that what? Mass number is 60 and number of proton is what? 27. I can answer 60 equals to N plus what? 27. To get number of proton, I will now have 60 minus 27 and is equals to N. Therefore, the number of proton is what? 33. Then now, what they asked me to get there, they said I should get, come over here to see the question. They said I should get proton. After proton, I should go to neutron. After neutron, I have what? Electron. So when I say proton, what is my proton? My proton is 27. That's what I have as a proton, which they gave me there. Look at the 27, my proton. And comma, what's the next? Neutron. What's my neutron? 33. And the next thing they asked me is electron. What's the number of electron? Number of electron is the same thing as number of proton. I get what I'm saying, huh? Which is what? 27. As I said, number of what? Atomic what? Number is the same thing as what? Number of electron. I get what I'm saying, huh? And that P is a what? Proton. I get what I'm saying now. You remember I said this is the atomic what? Number or number of electron. And you know that number of electron is same thing as number of what? Proton. Number of proton. Can you come over here? It's same thing as number of proton. Look at it. P is atomic number or number of electron or number of proton. You remember? So now here, what they asked me to get is what? Proton, which is what? This 27, and the what? Neutron, which we have calculated, which is 33, and the proton, which is what? 27. And my option here, coming to the option, I can now see that this option is not correct. I have this option not correct. I have this one not correct. I have this one, which is what? It's 27. 33 and 27. That's the option D is my what? Answer. My answer is option what? D. Yeah. This is question number 12. For a gas, the relative molecular mass is equal to 2y. Relative molecular mass is equals to 2y. What is y? Are you get what I'm saying? They say for a gas, the relative molecular mass is equals to 2y. What is y? The option given to me is this. I don't know. I cannot say solution to know which option is correct. I remember that relative molecular mass, which is what? 2y, is equals to what? 2 times vapor density. 2 times vapor what? Density. That's what I know. I could remember that. The relative molecular mass is equals to 2 times vapor density. Then they asked me what the y is. I can now say divide through by 2. If I divide through by 2, I have y divided 2y divided by 2 equals to 2 times vapor density. 2 times vapor density divided by 2. Dividing this by 2, I will have this cancel this, and this cancel this will give me y is equals to vapor density. I will now say the value of y is what? Vapor density. That's it. I'll go to my option. They say option 1, the mass of gas, B, the vapor density of the gas. We will now see that option B is my correct answer. I will now say my answer is what? Option what? B. That's it. There is the question number 13. Question number 13 says, to what temperature must a gas at 273 K, that's Kelvin, being heated in order to double both its volume and the pressure? Look at the question again. To what temperature must a gas at this being heated in order to double both its volume and the what? Pressure? Let's go to solution before I come to option here. Solution. I remember that the formula for what, which we call what, PV1 P1 all over what, temperature 1. That implies that my what, my V1 is this, my P1 is this, where my V1 is this, and the what, P1 is this, and my what, T1 is equals to what? Look at here. My T1 is what? 273 K. Then now, I want to come to this. We said that what? V2 is equals to what? 2 times my what? V1. What they say? To what temperature must a gas at what is being heated in order to double both its what? Volume. To double the volume, that means volume 2 should be what? 2 times V1. Are you get what I'm saying now? Double the what? The pressure, which is pressure 2, should be what? 2 times P1. Are you get what I'm saying now? Look at the P1 here. Then for it to double, the temperature for it to double become the word which you call what? T2 is the question mark. T2 is the question mark. For this man to be heated at this temperature, look at this man and look at the volume, look at the pressure, and look at the temperature they are. Then for them to be doubled, the volume and the pressure to be doubled, what will be the temperature at that double? Which is now, for them to double, that means for this man to double at this man double at this, means T. This is the temperature of T2 where they ask me. I want to say using the formula V1 P1 all over T1 is equals to V2 P2 all over what? T2. Then where this man, looking at it, I will now look making this man subject of formula. I'm going to make T2 subject of formula, which is one that asks me cross multiplication. I will have that T2 is equals to V2, that's it, equals to what? T1 times what? V2 P what? 2 all over V1 and what? P1. You remember what we said? That what? T1, look at it, T1 times V2 is already what? 2V1. V2 is what? 2 times V1 times P2 is equal to 2 times P1, which is 2 times P1 all over V1 and what? P1. Can I come over here? I can now say that my T2, are you coming over there? Is equals to what? T1 times what? 2V1 times 2P1 all over V1 P1. I can now cancel this, and this cancel this. I will have that this become T1 times what? 2 times 2. And I'll have my what? T2 is equals to what? 4 times T1. And what's my T1? My T1 is given to me as what? 273. Are you getting what I'm talking about? They give it to me 273, that's my T1. And I will have my T2 is equals to 4 times 6, 4 times 3 will give me what? 12. I write 2 carry 1. 4 times 7 will give me 14. 14 will give me 28. 4 times 7 will give me what? 28. Plus 1, that give me 29. I will write 9. I get what I'm saying now. I've taken 12 here. This is 12. This time is 12. This time this will give me what? 28. I have carried 1. I put 28. Give me 29. Carry 2. 4 times this will give me what? 8 plus 2 will give me 1092. And this will give me 1092 Kelvin. That's the temperature at which these gas will be doubled both volume and pressure. I cannot go to what my option there. I look at option A, it's not it. Option B is not it. Option C is not it. And option D is my answer. I would say my answer is a what? Option what? D. And that's the question number 14. A mixture of sand and the ammonium chloride and the sodium is best separated by. Look at the question. A mixture, they said a mixture of sand and the what, comma, ammonium chloride and the sodium is best separated by A. By what? They said A, sublimation, followed by what? Addition of water and the filtration. Then let's look at option B, sublimation, followed by what? Addition of what? Water and the vaporization. Then C, addition of water followed by filtration and the sublimation. Then D, addition of water followed by crystallization and the sublimation. Then solution, look at what I put here. We said sublimation, which we know that is what? Is a process where what? A solid substance goes into gaseous without passing through the what? Liquid state. It goes from what? Solid state to what? Gaseous state without passing through the what? Liquid state. That's what? Sublimation. And the only one that will perform it is what? Ammonium chloride. We said sublimation is first performed to separate ammonium chloride. Have you seen it? We use sublimation to remove what? Ammonium chloride, which is a what? A solid state of what? A substance, which goes into what? A gaseous state without what? Going through the what? The liquid state. Then from what? The mixture. After we have done that, the ammonium will what? Ammonium chloride will what? Disappear. Are you get what I'm saying? Ammonium will just, immediately we do sublimation, ammonium will just disappear. We begin to perceive it. It will just go and leave us with what? Chlorine. Chlorine will remain behind. The mixture followed by the what? Addition of water. Then why do we add water? To what? Dissolve the what? Sodium chloride. Because immediately this man have left sodium, ammonium have left. Chlorine will what? Left behind, because chlorine is not a what? A sublimation element. That it doesn't have the ability of what? Sublimating. It's only ammonia that has the ability of supplementing, moving from its what? Solid state to gaseous state. So while he's going, he will leave chlorine behind. And this chlorine will react with sodium to form sodium chloride. And by adding water to that sodium chloride, we dissolve it. And while we have dissolved it, we follow by filtration. Because when we dissolve sodium chloride, we what? Filter the sodium chloride towards solution from the what? Sand. Because this sodium chloride are still with the sand, and when we add water, we filter it out. So we now see that option A, sublimation, followed by what? Addition of water and what? Filtration is the correct option to what? Do this. That's the question number 15. Question number 15 said, which of the following physical properties decreases down a group in the periodic table? Can we read it again? Which of the following physical properties decreases down a group in the periodic come over here table? And the option they give me: atomic radius, B, ionic radius, C, electropositivity, D, electronegativity. That implies all these things are physical properties of a what? Of a periodic table. Then we will now come to solution. We now say that atomic radius increases down the group as atomic size increase. That means as atomic size of an element increases, its atomic radius what? Increase. Just like somebody that have one child and later born another child, added to be two, you see that what? The atomic radius of that family will continue increasing. As they have what? You can't compare somebody that have one child to compare to somebody that have what? 5 child. So atomic radius will keep on what? Increasing. Then what they said, but it decrease across the period. That means atomic radius increases down the group as atomic size increases, but it decreases across the period. So this atomic radius decreases across the period, but increases down the group. This atomic radius of an element increases down the group and decreases across the period. It decreases across the period. That means atomic radius is not among. What they ask us is the one that what? Decrease down the group. The question said decrease down the group. Out of this, which one decreases down the group? That's what the question is all about. Can we get here? It means that what? What it means that what? What they are asking us is what? Among the physical property, which one decreases down a group? We now see that atomic radius increases down the group. It doesn't decrease down the group. Rather, it decreases across the period. That made this man off from the question. Then ionic radius, that where we are, ionic radius. Ionic radius generally decreases across the period. It decreases across the period as atomic charge increases. But what happened? It increases down the group. It increases down the group, but it decreases across the period. And that word made him what? Out of the word point. But let us know something about this atomic radius. We said that atomic radius decreases across the period as atomic charge increases, but increases down the group. Then let us, I said thoughts. Positive ions, metal, that's what it means, metal ions are smaller than their parent atom. What does it mean? That is, sodium ion is smaller than the what? Normal sodium what? Element. Neutral sodium is smaller. That's it. Sodium ion is smaller than what? Neutral sodium. Why? Because this sodium have lose an electron. And when a metal lose electron, what will happen to that metal? It will shrink. The more, it will contain more what? Proton, which will shrink the what? The element or atom. So for this part to lose the electron, it will be smaller than the what? When he has not what? Lose. When he have not reacted to what? When he have not performed any reaction. That I said that imply. This means imply its radius is smaller than what? This. That means this man radius is smaller than this man when he lose what? Electron. When he lose what? Electron. And I said calcium ion is smaller than what? Sodium ion. Why? Why calcium ion is smaller than sodium ion? This man have lose 2 electrons, so it will be more shrink. It will be more bereave when somebody lose 2 child and when somebody lose 1 child is not the same. So this man will be more bereave in the sense that it will shrink more than the word sodium ion. That means its radius is smaller than sodium what? Ion. As it shrink, its radius is smaller than sodium ion. Then aluminium. Looking at aluminium ion, he has lose 3 electrons. As aluminium ion lose 3 electrons, is smaller than what? Sodium what? Sodium what? Calcium what? Ion. Is smaller than calcium ion. Why? Because he has lose 3 electrons against 2. So it will be more shrink than this. So its radius is smaller than the what? Calcium what? Ion. Negatively charged ions, which we call non-metal ions, are bigger than their parent atom. That is, they are bigger than their parent atom. What does it mean? You know that non-metal ion, they gain electron. They don't lose, they gain electron. And when they gain electron, they will be more big. Their size will increase. That's what we mean here. So when this man gain electron, his size will what? Increase. We now say that chlorine ion is bigger than when he has not taken part in the reaction, which is what? Chlorine, parent chlorine. It means its radius is bigger than what? Chlorine. What does it mean? This man have gained electron and what? Swallow up than it what? Normal chlorine. Then oxygen will gain more 2 electrons because chlorine needed only one electron to what? Be rotated. When oxygen needed 2. So oxygen will be more bigger than what? Chlorine ion. Oxygen ion will be more bigger than chlorine ion. That implies its radius is bigger than the what? Chlorine ion. Then we now come to what? Nitrogen ion. Nitrogen require 3 electrons. So for him to require 3 electrons, it means that it will be bigger than what? Oxygen. And it's bigger than what? Oxygen what? Ion. Its radius is also bigger than oxygen what? Ion radius. We come to what? Electropositivity. Electropositivity, which we call positive ions of ionic radius. Positive ion of ionic radius decreases across the period but increases down the group. You say what? It decreases across the period but increases down the group. I'm listening it here. So you now see that what? This man, come over here, this man is out of the what? The equation. This man is out of the equation. Ionic radius is out of the equation. It doesn't decrease down the group. Electronegativity doesn't decrease down the group. Electronegativity is the power of an element, non-metal, in a molecule to attract electron. Electronegativity is the power of an element which is non-metal. Electronegativity is associated with non-metal in a molecule to what? Attract electrons. So when we say electronegativity, we are talking about what? Non-metal. Then I now come back here to tell you that electronegativity increases across a period. Increases across a period but decreases down the group. Have you seen it? He decreases what? Down the group. We said he increases across the period but decreases down the group. We will now see that electronegativity is a man that decreases down the group, but what? Increases across the period. Among these people now, you will now see that it's only this man, among these people listed to us, look at it, atomic radius, ionic radius, electropositivity. Only this electronegativity is the one that decreases down the group. And I come down here to say increasing order of electronegativity is, look at this, increasing order of electronegativity is fluorine is more electronegative than chlorine, and chlorine is more electronegativity than what? Bromine, and bromine is more electronegativity than what? Iodine. Then that's the order of their what? Increasing order of what? Electronegativity. But we have already now found out here that increasing across the period was electronegativity, but it decreases down the group. That means my answer, because what they ask me here is that what? Which of the physical property that decreases down the group among these options? I cannot say my answer is a what? Option what? D. Then after we have gotten this answer, let us also note this. Ionization energy is something as an ionization potential. When I call ionization potential, I'm talking about an ionization what? Energy. And is the energy required to remove an electron, come over here, to remove an electron from the atmosphere of an isolated gaseous atom or ion. Isolated what? Gaseous atom or what? Ion. So this is the energy required to remove, for you to knock out an electron from what? And this ionization energy is associated with a what? Metal. It's only metal that what? Has the properties of what? Ionization energy. Because he is the one that releases the what? Electron. So the energy required to remove one electron from a metal is what we call what? Ionization energy of that what? Metal. Are you get what I'm saying now? So you will not see that ionization energy of sodium is less than ionization energy of what? Calcium. Energy required to remove one electron from sodium is less than energy required to remove 2 electrons from what? Calcium. Are you get what I'm saying now? You see that calcium have to give out 2 electrons. So the first ionization energy of what? Calcium is less than the second ionization energy of what? Calcium. Because calcium has 2 ionization stage. Calcium can give you what? 2 electrons. Therefore, since he can give 2 electrons, he has 2 ionization stage. The first ionization energy is when he gives 1. The second ionization energy is when he gives the second one, with the all he has. So the second ionization energy is higher than the first ionization energy. Just look at an example. When somebody come and beg you first time, give me pen to write something. The person give you the pen, you write and throw away the pen. Later you go back to the person to give you again another pen. What will happen? Even though the person is your friend, it will react. It will tell you what of the one I gave you before. So it's not as you get it at the first time that you will get it the second time. There must be some questions. So that's what we call ionization energy. We say ionization energy increase. Look at it now. Ionization energy increase across the period, but also what? Decrease down the group. You will now see that ionization energy decrease down the group and increase across the period. That means ionization energy and negativity has the same what? Properties, which we call what? Increasing across the period and decreasing down the group. Ionization energy and what? Electronegativity. Ionization energy and electronegativity has that the same properties of what? Increasing across the period, decrease down the group. Then let's also look at what we call electronegativity. And I say that electronegativity is the energy released. Energy released when an electron is added to what? Atmosphere of an isolated neutral atom in the gaseous state. What does it mean? It means that electron affinity goes with what? Non-metal. He is the one that what? Gain electron. So when electron is given to this man, energy release for such electron to be what? Given is what we call, look at the energy, it's what we call what? Electron affinity. We said that look at the reaction, look at the neutral atom, added electron to him, it will now what? Have electron in excess. Look at this minus, meaning having electron in excess, which are associated with what? Non-metal, and the energy will be released, because for you to force yourself into a family, there will be a what? Energy you require, which will sweat will come out from your body. Then electron affinity decreases down the group, but increases across the period. And this is the order of increasing order of the electron what? Affinity is given as what? Chlorine has more than what? Fluorine. Fluorine has more than what? Bromine. Bromine has more than what? Iodine. Then note it now that electron affinity and electronegativity and the ionization energy have the same trend in a what? In a periodic table. What do you mean by trend? They increase across the period and decrease down the what? Group. They increase across the period and decrease down the group. That they have the same trend in the what? In the periodic table. Then also look at the option here. Atomic radius and ionic radius and electropositivity has the same trend. Are you getting what I'm talking about? What's their trend? They what? They decrease down the what? Period. They decrease across the period, but increase down the group. They decrease across the period, but they increase down the group. These people, this man and this man and this man, increase down the group but decrease across the period. So they have the same trend. So this and this and this has the same trend. While electronegativity and electron affinity and the ionization energy has the same trend of decreasing down the group and increasing across the period.